Run that over here, and then you just run this on over. And set it there. Didn't do. Later we'll pressure test the still with that pressure testing device. Just make sure I can get a hook onto this one. Oh yeah, I think we're in good shape.
I wanted to talk about these ridges on this still, and you'd think that perhaps they were for pressure, that somehow it was the pressure of the still pushing up and you needed to reinforce it. Actually, these are for negative pressure, because when you turn this thing off at night, if you don't want to let the alcohol evaporate, although you could open up the safety valve over there, but this thing will just get a tiny little bit of negative pressure and it wanted to collapse. So that's why we put these things on here. These things are on snug, and we pressure checked the still to 3 pounds before we started, and it never gets that hot now, or that pressurized at this point.
Probably the safest time to check the still pressure is today, while the still isn't running and I'm not trying to run a batch. If it's not going to seal, now is the time to find out about it. Like a football. We still haven't got to 2 pounds yet. Now you can see that we've got lots of air in there, but we need to make sure this is going to take still temperature, still pressure. These are the safety valves here, okay? And we can adjust these so that they will allow steam to leak off if the pressure gets too high. This is 2 pounds, moving up on 3 pounds. That's enough for today. So we'll just wait for the still run to bleed off all the pressure.
What I also learned is that now that this coil is right-sized for this still, this 1 1/4 inch, that opening up both coils does not increase the flow rate of the still. So I know that I've achieved a balance where I don't need any more condensing capacity. What I have is adequate, and that's what we were looking for. I started out with a 1/2 inch coil. It didn't work. I went to a 3/4 inch coil. It didn't work. I went to a 3/4 inch coil with the 1/2 inch coil. That worked better. But what really solved the problem was finding this larger copper and putting it to work.
10 degrees still. So we've got a temperature differential in this tank of 100 degrees from top to bottom. Over time, the temperature gradient will move down here, and it'll be 205 degrees farther and farther down into the tank, and eventually the bottom of this tank will finally get hot at the very end of the run, and we'll know the run is over. Also, the proof will go down. But even if you put heat in the bottom, it will tend to collect on the top. You're always going to have a temperature differential between the top and the bottom of your tank. But I know that it's decreasing the total pressure on the still lid, because not only do I have a 3/4 inch pipe there for steam to get out, I also have a 1/2 inch pipe here for steam to get out. So the cross section is greater, and I'm using both condensers.